Welcome back, everyone. In this video, we'll be looking at example 1.5.7. I'll show you how to use a method similar to this method that we learned for En, but that would work for any span in any vector spaces. So we'll look at W, which is a subset of the set of 2 by 2 matrices. So W is the span of 1, 3, 1, 0, 4, 5, minus 3, 7, minus 1, 0, 2, minus 3, and 1, 4, 2, minus 1. And I want to find a basis for W. All right, so really what I'm going to start with is the same thing I started with here, trying to figure out whether this is a linearly dependent set or not. So I'm going to try to write 0 as A1, A1. So this would be A1 plus A2, A2, where the next matrix is A2, plus A3, A3, plus A4, A4. All right, so let's spell this out a tiny bit more. I get 0, 0, 0, 0 equals A1 times 1, 3, 1, 0 plus A2, 4, 5, minus 3, 7 plus A3, minus 1, 0, 2, minus 3 plus A4, 1, 4, 2, minus 1. All right, so that would mean if I put it all together, on this side I would get A1 plus 4A2 minus A3 plus A4 equals 3A1 plus 5A2 plus 4A4. I'll get A1 minus 3A2 plus 2A3 plus 2A4 equals, and then the final entry would be 7A2 minus 3A3 minus A4. All right, so I get a linear system just like I did in the case of En. I would get a linear system, A1 plus 4A2 minus A3 plus A4 is 0, so that's for the first entry. If I look at the second one, I'll get 3A1 plus 5A2 plus 4A4 is 0. And then A1 minus 3A2 plus 2A3 plus 2A4 is 0. And finally, 7A2 minus 3A3 minus A4 is 0 as well. All right, so I get a matrix. Again, the constants are 0, so you don't need to include them. They will just stay 0 throughout the reduction. And so you can just look at the coefficient matrix. So this is the one I got. I already reduced it as usual to avoid some repetition. All right, so 5 sevenths minus 3 sevenths, 0, 0. 11 sevenths minus 1 seventh, 0, 0. Now, I claim that this reduction tells you everything you need to know. It tells you that if I keep only the two first vectors, they would be linearly independent because I would end up having only one solution. So I will keep these. And then these two columns here give you recipes to rewrite A3 and A4 in terms of A1 and A2. All right, so let's spell this out a bit more. So the third column tells me that A3 is 5 sevenths A1 minus 3 sevenths A2, and it tells me that A4 is 11 sevenths A1 minus 1 over 7 A2. All right, so that tells you that A3 and A4 are redundant, so you don't need them. So what I would take for a basis is just A1, A2. So that's just 1, 3, 1, 0, and 4, 5, minus 3 sevenths. And because I have these leading ones, when I reduce, I know that these are linearly independent matrices. They're not multiples one of the other. And then I know I can get A3 and A4 because I have recipes for them, so I will get the same span. All right, so the idea is pretty simple. When you apply something like this, you would keep the vectors that correspond to leading one. If they're vectors, if they're matrices, you keep the matrices corresponding to leading ones. And then every other column gives you a recipe to build one of the original generators in terms of your basis.